Okay, so I'm just going to say it. Based on the massive stack of source material we are diving into today, I am like absolutely convinced that Nvidia is basically building Skynet.
Oh, here you go.
No, seriously. And its CEO, Jensen Huang, he is clearly a time-traveling cyborg sent here from the future to code the Matrix. I mean, think about it. The sheer computing power, the relentless pace, the signature black leather jacket, it all adds up perfectly.
Right. Well, I checked the math, and it's a mess, but I love the chaos.
Thank you. I appreciate the validation.
I mean, actually, he's just a guy who used to scrub toilets in Kentucky and wash dishes at Denny's. But sure, yeah, let's go with time-traveling cyborg.
Listen, you really can't blame me for jumping to sci-fi conclusions here, because we are doing a deep dive today into Stephen Witt's biography, The Thinking Machine, and man, this book is dense.
Oh, it really is.
It is packed with so much silicon architecture and high-stakes business strategy that my brain is basically like short-circuiting right now.
Tell me about it. I mean, it took me 4 espresso shots just to get through Chapter 3's explanation of parallel computing architecture alone.
4 shots.
At least.
Yeah.
It gets incredibly technical, but, if you push through, the payoff is genuinely staggering.
It really is. So to you listening right now, here is our mission for this deep dive. We are going to uncover exactly how a scrappy, failing video game hardware startup accidentally built the engine for the entire artificial intelligence revolution.
Accidentally being the operative word there.
Right. And more importantly, what that means for your future. Because let me tell you, this whole origin story is a total mood.
It really defies logic in a
Yeah.
lot of ways. If we connect this to the bigger picture, to understand how someone builds a $3 trillion company that essentially creates the bedrock of the future, you really have to look at the brutal reality of their past.
Yeah.
The schools required to navigate hyperscale computing were actually forged in rural Kentucky in 1973.
Okay, that part of the book blew my mind. So Jensen is just 10 years old, right?
Yes.
He gets sent from Thailand to the Oneida Baptist Institute, which his uncle thought it was this prestigious elite prep school.
Right, a classic mix-up.
But it was definitely not. It was a juvenile reform academy.
A very harsh one, too.
Yeah.
I mean, you have a tiny 10-year-old immigrant who barely speaks English, and he gets placed in a dorm room with an illiterate 17-year-old knife fighter.
A knife fighter.
Yeah, a guy who, on the very first night, lifted his shirt to show Jensen his stab wounds.
That is terrifying. But instead of crumbling or, hiding under the bed, Jensen makes this incredible deal. He agrees to teach the knife fighter how to read.
Right.
And in exchange, the older kid teaches Jensen how to bench press, which, by the way, started Jensen's lifelong habit of doing 100 push-ups every single day.
That's dedication. What's fascinating here is the sheer adaptability of it all. I mean, he had the daily chore of cleaning the school's latrines. He survived bullies who would literally try to shake him off a rickety rope suspension footbridge over a freezing river while he was walking to class.
Like an Indiana Jones movie.
Basically, yeah. But he didn't complain. He just learned to put his head down, master the fundamentals of survival, and fight back.
I can't even imagine being 10 and dealing with that. And that gritty survival instinct, it doesn't go away. So if we fast forward 20 years to 1993, Jensen, along with his co-founders Chris Malachowski and Curtis Prime, they decide to launch Nvidia.
Right, the big leap.
And where do they draw up the corporate paperwork? Not in some sleek boardroom. They are at a Denny's in San Jose, a location so incredibly rough that the window they were sitting next to had literal bullet holes in it.
From people shooting at the police, no less.
Yes, insane.
It's the ultimate unglamorous Silicon Valley origin story. But it's important to understand that they weren't, like, overnight geniuses. Their first big swing was a massive existential miss.
Oh yeah, a huge swing and a miss.
They built their first graphics chip, the NV1, based on an obscure architectural concept called quadratic texture mapping.
Okay, I was so confused by that part. Quadratic texture mapping sounds incredibly futuristic, but the book says it was a total disaster that caused catastrophic blue screens of death. Why did it fail so badly?
Well, think about how 3D graphics are usually built. The industry standard became triangles.
Yeah.
Stitching millions of tiny flat triangles together to create a 3D shape.
Right, like old school video game polygons.
Exactly. It's mathematically simple. But Nvidia tried to use curved squares. That's the quadratic part.
Curved squares.
Yeah. Mathematically, it's elegant, but practically, it didn't play nice with standard software at all. When gamers tried to run games on the NV1, Characters would sink into sidewalks or pass straight through walls.
Oh, man.
It just couldn't render the physics of the games properly.
Oh, wow. So they basically bet the farm on curved puzzle pieces while the rest of the world was using straight edges.
Pretty much.
And that almost killed them, right? I mean, customers were returning the chips. They had to lay off almost everyone, dropping down to just 35 employees. They were entirely broke.
Exactly. And this is where Huang gambles everything. To manufacture a physical microchip, to tape it out at a fabrication plant that costs millions of dollars.
Which they did not have.
Right. And if there's a bug in the physical silicon, you can't just hit undo. You lose millions. Since they were out of cash, they couldn't afford to print prototypes for their next chip, the NV3. So Huang spent their absolute last bit of money on a software emulator.
An emulator. So basically a massive supercomputer that pretends to be the chip before it physically exists.
Precisely. It allows you to run the chip's logic in a digital simulation to spot fatal bugs before spending millions on manufacturing.
That is like jumping out of an airplane and trying to sew your parachute together on the way down.
It's a very high-stakes parachute.
How do you even convince a team of exhausted engineers to work under those conditions without everyone just quitting on the spot?
Well, you institute a state of permanent manufactured panic. Huang adopted a corporate mantra right then and there. He told them, our company is 30 days from going out of business. He drilled it into them so hard that desperation became their actual business strategy.
Wait, I'm looking at my notes here, and that paranoia explains so much about their next move. Because if you think you're always 30 days from death, you don't play it safe.
You can't afford to.
But even still, their next big bet on parallel computing alienated everyone. If they built this amazing tool for scientists, why wasn't Wall Street thrilled? Scientists have huge budgets, don't they?
You'd think so, but let's break down the actual math of the market at that time. Wall Street cares about massive, scalable consumer markets, like mobile phones.
Sure, millions of units.
Right. But Nvidia was pouring billions into research and development for parallel computing. To understand this, let's look at the book's analogy.
Okay.
You're listening to this on a smartphone right now. The primary chip running your apps is a CPU. Think of a standard CPU, like the ones Intel makes, as a beautiful, highly precise Wüsthof chef's knife.
A chef's knife, okay.
It cuts one vegetable perfectly, sequentially, one at a time. It's elegant and incredibly fast for single logical tasks.
But NVIDIA's GPUs, their graphics processing units, are not chef's knives. They are like a loud, indelicate Cuisinart food processor.
Exactly. A GPU can't do the fine sequential slicing, but it has thousands of tiny cores that can mince massive piles of data all at once, simultaneously. That is parallel computing.
Right.
And in 2006, NVIDIA released CUDA. It was a software layer that essentially allowed anyone to flip a switch and turn their gamer graphics card into an incredibly powerful supercomputer to crunch massive amounts of data.
But again, investors hated this. Activist investors were literally threatening a proxy fight to take over the company.
Because they saw scientific computing as a quote-unquote $0 billion market. Wall Street looked at it and said, okay, you've built a supercomputer, but your only customers are a few thousand weird academics in university basements.
Yeah, they're not buying millions of these things.
Exactly. They buy a handful of chips. Wall Street basically said, you are burning our money.
But Jensen was obsessed with Clayton Christensen's book, The Innovator's Dilemma. And here's where it gets really interesting to me. Jensen's strategy wasn't to fight Intel head-on in the CPU market.
No, that would be suicide.
Right. He deliberately targeted these marginal low-profit customers, the scientists, to build a moat so deep that massive competitors could never disrupt them.
That's the genius of it.
Yeah.
By constantly accepting tech debt and taking insane financial risks to serve these tiny academic markets, NVIDIA was quietly building an architecture no one else on Earth had.
And I am just so hyped about the realization that teenagers aggressively playing Quake and Doom in their bedrooms were accidentally funding the world's greatest scientific supercomputers.
Yeah.
I mean, every time a gamer upgraded their rig to shoot virtual aliens faster, they were subsidizing the R&D that would literally change the course of human history.
Yes, and it's a brilliant paradox, really. By ignoring Wall Street and surviving almost entirely on gamer revenue, NVIDIA essentially became the only company capable of answering the call when the massive data revolution finally hit.
They were just waiting for it.
They built this giant multi-lane parallel highway, but nobody was driving on it yet. To understand who finally showed up to drive on it, we have to look at the artificial intelligence establishment.
The outcasts. The neural network researchers.
Right. For decades, the AI establishment absolutely hated neural networks. The traditional approach to artificial intelligence was called GOFAI, good old-fashioned AI.
Catchy.
It was entirely based on probability, rigid logic, and writing explicit rules for the computer to follow.
Which works great for, like, playing chess, but you can't write a mathematical rule for every single pixel in a picture of a cat. The real world is just too messy for rigid rules.
Exactly.
But the traditional AI guys were definitely gatekeeping the best parts of the science. They wouldn't even let neural network papers into their academic conferences.
Because neural networks, which try to mimic the biological structure of the brain by learning through trial and error, required an absolutely absurd amount of simultaneous math.
Which the CPUs couldn't handle.
Right. Standard CPUs, those Wusthof chef's knives, would take months to process a simple image recognition task using a neural network. So the establishment considered it a total dead end.
But then comes 2012, and the wall totally breaks. Researchers Jeff Hinton and Ilya Sutskever up in Toronto realized that if neural networks need simultaneous math, gamer graphics cards do simultaneous math to render pixels.
The light bulb moment.
Yes. So they take two cheap Nvidia gamer cards, use CUDA, and run an AI model called AlexNet.
And AlexNet enters a prestigious computer vision contest and utterly crushes the traditional rules-based AI models. It wasn't even close.
Not even a little bit.
The machine had learned to see. Suddenly, the entire computer science world realized that neural networks, powered by NVIDIA's parallel computing, were the absolute answer to artificial intelligence.
Okay, so they conquer computer vision, but what about language? Because ChatGPT isn't just looking at pictures of cats.
This is where we get to the transformer architecture in 2017. A researcher at Google named Jacob Uskereit, he's the T in ChatGPT, realized that you could process human language using the exact same parallel logic.
Really? How?
Well, before this, AI read text sequentially, one word at a time, just like a CPU. Uskereit invented a mechanism called self-attention.
Okay, I struggled with that concept in the book. What exactly is self-attention doing?
Instead of reading a sentence left to right, self-attention looks at how every single word in a massive document relates to every other word simultaneously.
Whoa.
It holds the entire context in its mathematical memory at once. And because it's doing everything simultaneously, it maps flawlessly onto NVIDIA's parallel GPUs.
So you don't need a chef's knife to read sequentially anymore.
Right. You need the Cuisinart to blend the entire dictionary at once.
And that realization triggers absolute madness in the tech industry. This leads to hyperscale computing. Google launches Project Mac Truck, buying tens of thousands of GPUs.
They bought everything they could.
And Nvidia realizes they aren't just selling graphics cards anymore, so they build the DGX-1, a $129,000 supercomputer specifically designed just for AI.
Which fundamentally changed the scale of data centers worldwide. They had to figure out how to connect these massive chips together so they could share data without bottlenecks.
Okay, you're killing my vibe with these facts. I want to talk about the AI superbrains, because trying to connect these chips together, I was reading this and it's like they had to invent a giant fire hose just to shoot the math back and forth, right?
You're on the right track with a fire hose.
Uh-huh.
The book actually describes the connection technology they invented, called NVLink, as essentially a homework cannon.
A homework cannon.
Yeah. It fires 1 million semesters worth of math at the processor every single second. Standard computer wiring physically couldn't handle the bandwidth.
A homework cannon. I love that so much. But it's also like a little terrifying. And if we connect this to the bigger picture, you don't scale a technology that alters the course of human history just by being smart. You do it through sheer, almost terrifying force of will.
True.
Which brings us back to the paradox of Jensen Huang.
He is a fascinating contradiction. I mean, on one hand, he wears this immaculate Tom Ford leather jacket. He cooks gourmet meals for his friends. And the book details how he quietly, secretly pays for sick employees' medical bills out of his own pocket.
Which is amazing. But he is also genuinely terrifying to work for. There is a phenomenon known internally as the wrath of Huang.
Oh, the wrath.
The book describes a moment where he screamed at senior executives for 2 hours straight in the company cafeteria in front of 150 people.
Just to enforce his scheduling philosophy.
Yes.
Ah, yes. The speed of light scheduling. This is central to how NVIDIA outpaced Intel. Huang demands that teams figure out the absolute physical limit of how fast a project can theoretically be done.
Like ignoring all human needs.
Right. If everything goes perfectly and physics is the only constraint, how fast can we build this? And then he forces the engineering teams to work backward from that impossible timeline.
It creates an incredibly intense, high burnout environment, but it works. Yet, as this hyperscale computing took off, it didn't just stress out the employees, it started to genuinely scare the very pioneers who invented the technology.
Those things took a turn.
This is where we see the rise of what's known in the industry as the fear, or P-doom, the probability of doom.
This raises an extremely important question, and it's one the book presents from multiple perspectives very impartially. On one side, you have AI pioneers like Jeff Hinton and Yoshua Bengio, who became deeply concerned.
Right.
Hinton's fear is centered on runaway self-improvement. He worries that if an AI system develops even the tiniest inherent drive to improve its own code, it could rapidly spiral into a superintelligence that takes control of resources, effectively pushing humans out of the picture.
And as someone reading this, I'm thinking, what if the doomers are right? We are building the infrastructure for a digital brain that can think a million times faster than we can. This feels like the prequel to every sci-fi apocalypse movie ever, and we are the ones plugging the machine into the wall.
Well, to balance that perspective, we have to look at how other experts, like Jan LeCun and Jensen Huang himself, view the technology.
Okay, what do they think?
LeCun argues that the drive for dominance is a biological, evolutionary trait unique to social animals. We compete for resources because we evolved in nature. He believes AI will remain completely subservient because it lacks those biological dominance drives.
So intelligence does not automatically equal a desire for power.
Exactly.
And Huang, he absolutely refuses to entertain the doomerism. To him, AI is simply software processing data, nothing more, nothing less.
He's very firm on that.
There's a wild detail in the book where Huang actually exploded in anger at the author for bringing up an Arthur C. Clarke sci-fi quote about machines outthinking us. Huang literally screamed that Nvidia is doing serious work and isn't a sci-fi movie.
He fundamentally rejects the anthropomorphism of AI. He doesn't see a conscious entity waking up inside his servers. He sees an incredibly efficient calculator that is following mathematical weights and biases.
So what does this all mean? Let's tie this incredible journey up for you listening. You have this 10-year-old immigrant who had to fight off bullies on a rope bridge in Kentucky.
Right.
He takes that exact same brutal survival instinct, applies it to the cutthroat semiconductor industry, accepts insane tech debt, survives near bankruptcy, and effectively births the next industrial revolution using video game hardware.
It's a remarkable synthesis of strategy, luck, and just sheer determination. But it leaves us with a provocative thought to consider.
Ooh, lay it on me.
If NVIDIA's hardware continues scaling at the speed of light and brings us to what some researchers call the solved world, a reality where the marginal cost of doing complex math, generating art, or applying human-level intelligence goes to absolute zero,
Yeah.
what is the actual purpose of human effort? Are we destined, as one researcher enthusiastically suggested, to simply be zoo animals for a space computer?
Wow. Okay, zoo animals for a space computer. I am going to be staring at the ceiling thinking about that all week.
While you're staring at the ceiling, I have a homework assignment for you and for our listener.
Oh, boy.
Read Clayton Christensen's The Innovator's Dilemma. And then I want you to find one aspect of your own life where you can apply Jensen's speed of light timeline, figure out the physical limit of what you can accomplish, and work backward.
That sounds entirely too much like actual work. I'm just going to ask ChatGPT to summarize the book for me and figure out my life schedule.
Typical. Well, until next time, keep your eyes open and try not to get replaced by a time-traveling dishwasher.